Do you want to save 20 to 30% of your building's yearly utility costs? Well, today's problem solved is brought to you by Parity, New York City's leading HVAC optimization service for condos and co-ops. Hundreds of property managers, board members, and resident managers trust Parity to improve their building's energy efficiency and save 5 to 6 figures on utility costs each year. To learn more, visit paritygo.com or email contact@paritygo.com.
Welcome to Problem Solved, a conversation about challenges facing New York co-op and condo board directors. I'm Emily Myers with Habitat Magazine, and I'm joined by Amalia Cuadra, Senior Director of Engineering at npower Group. Amalia, thanks for being here.
Thanks for having me.
We're going to talk about energy efficiency, why poor design might be part of the problem, and what boards can do about it. We'll discuss why it's so important to design upgrades holistically, and how phasing in these improvements can be helpful in getting the upgrades right. So let's kick off with a look at One Grand Army Plaza, a 99-unit all-glass condo in Brooklyn's Prospect Heights. Amalia, you've worked with this building for a while, but what's been the most recent concern for residents?
So yes, we've been working with One Grand Army Plaza since 2020, right in the middle of the pandemic. And I have to say that one thing that's kind of cool about One Grand Army Plaza is that it's in directly my neighborhood. So I was excited that we had this opportunity. Back in 2020, we worked on a chiller replacement, boiler replacement, and a domestic hot water system replacement. Obviously, there was design and construction during, some tough periods because of the pandemic, but that project went well. And the building did see significant improvements in energy. As we were working through the project, the property manager, Margie, kept asking me questions about this rooftop unit. And the rooftop unit, One Grand Army Plaza, is designed like a lot of multifamily buildings to supply fresh air to the corridors. And it goes from the corridors into the apartments. And then the kitchens and the bathrooms exhaust that air and just kind of keep fresh air coming in. But one of the issues that there were several issues that they were having with this rooftop unit. On it during the summer, it never cooled, right? You're supposed to provide some comfort when you bring in fresh air. You can't just bring really hot air, really humid air, or really cold air. You're supposed to, temper that air. But in the summer, they couldn't meet the loads. It was always really hot. And they had spent a lot of money repairing the compressors for that unit, somewhere in I want to say more than $50,000, and they knew the unit was not doing well. So they wanted me to spend some time looking at it. And in reviewing, I realized that they had several issues with this rooftop unit. One, the unit was never designed to fully provide the cooling that the building needed when you brought in fresh air. The sizing of that unit was not made for that. So they had over time tried to overcome that. And some of the repairs that had been done actually kind of hurt the performance of the unit. But one of the biggest issues that this unit had was the way and where it was designed. So the rooftop unit, it's obviously on the roof, one gap has a cooling tower. And the cooling tower is literally right next to the rooftop unit. The cooling tower is like maybe 20 feet lower. So a cooling tower operates in the summer, and it rejects the heat from the building. And that heat is humid, and it goes up. And the fresh air intake of the rooftop unit was very close to that cooling tower, right? So that was a big issue because you were introducing humidity into the hallways.
So what you're saying is the position of the fresh air intake unit was wrong right from the outset.
Oh, 100%. So One Grand Army Plaza was constructed in 2008. So right as we had the big recession, and I think towards the end of construction, they took a lot of shortcuts. And that was one of the shortcuts that they took. It could have been designed that way from the onset. I had a conversation with one of the doormen at the building who had been there since the beginning. He said that unit never worked correctly. Now we know why, right? Because we're introducing humid air into the fresh air intake. Now this humid air, it's hot, right? Humidity has a lot of what's known as latent heat. It's just a different type of heat that's really hard to remove. And then we're expecting to cool it with the unit that was never designed truly to be able to reduce that, right? And then on top of that, we've data mechanics had done all these changes to the unit to make it work without really trying to get to the heart of it.
So your issue was dealing with efficiency and comfort in the ventilation systems. And what did you conclude?
Yeah, so based on my conversations with Margie, I said, look, Margie, this unit is you're going to have to replace it. It needs to be placed into the capital budget of the building. But I don't think it's a good idea just to replace the unit. I think you have to have a holistic approach to the replacement of the unit because, I talked about how the rooftop unit provides fresh air to the corridors, goes into the apartments and the kitchens and bathrooms exhaust. And that system is meant to work together. I said, if we replace the unit, we have to replace the unit in a way that meets the ventilation rate of your exhaust fans, because both are meant to work together. If I'm able to come down in volume and CFM for the RTU, I'm limited by what's going on the exhaust fans.
So can I just so that we don't get lost in some of the technical language,
Yeah,
the CFM in this context stands for cubic feet per meter, a measure
exactly.
of air volume being pulled through the
Exactly.
system. And
Exactly.
so what you're working with is kind of moderating that air
Exactly.
volume being pulled in to the building,
Yeah.
but also making sure that it's not pulling in humid air when it doesn't need to be.
Exactly. But looking at the exhaust fans, I also realized the exhaust fans were oversized, right? So one unit is providing the volume it's supposed to be doing, but not the cooling capacity it has to. And then on the other side of the equation, I have fans that are exhausting really high volumes. So I said, I talked to the board, obviously to the property manager. If you're going to do this, my recommendation is that you do the reason being is because if you're able to bring down your exhaust volume, you're going to be able to also bring down your supply volume in a way that you're meeting indoor air quality requirements, the cooling load, because that can be sized properly, and then just have this holistic approach. Now, the other part of the conversation is that also the cooling tower was starting to have mechanical issues as well, because the RTU, the rooftop unit is about, 17, 18 stories high in the air. The cooling tower is one floor below. If you're going to use a crane to bring the rooftop unit, and in 3-4 years, you're going to bring another crane to replace the cooling tower, that you're going to have to spend an extra $150,000 just for renting equipment an extra day. So the building made the decision that they wanted to do kind of like this phase of the project was 3 parts. Replace the rooftop unit, replace the cooling tower, and replace the fans. And while we're replacing the fans, we're also going to seal the ducts to make sure that any leakage that's coming from the ducts gets addressed. So it's a capital project that's coming from a comfort need, but we're also addressing energy conservation, carbon emissions reductions, building operations, efficiency, because there's a lot of things that we improved during our design.
And so what you're saying also is that there are cost savings to combine projects involving cranes to get equipment to the roof.
Oh,
as well.
100%. Yeah.
Yeah.
You
So-
use the crane for an hour, you're still going to pay at least $100,000.
Yeah. What
Yeah.
is the cost for the project then for this building?
The cost of the cooling tower and the rooftop unit, they're somewhere around $900,000
Okay.
combined. That includes work associated with obviously the new equipment. We put new grading around the rooftop unit from a safety component because that also needed to be addressed. For the cooling tower, there's a lot of steel damage around the unit that we cleaned up. And the new cooling tower is also a cooling tower that's using much more efficient mortars. Like new technology allows you to be about half the size in the mortar instead of having I forget the exact size of the motors, but I think we went from 220 horsepower to 210. So I'm confident about the fact that we have.
And so, what kind of savings are you generating then? Can you put a number on that?
We finished the project in October. We rigged in October. So the rooftop unit has been operating to provide air and, but it's heated air. The efficiency of the rooftop unit from a cooling perspective was better than the old unit, obviously. And then the cooling tower hasn't run. We expect it to start running in about, 2 months period, maybe a little bit. It's a glass building, so they need cooling earlier. But we expect the savings to be about 250,000 kilowatt hours. And on therms, I don't remember exactly like how many, but it was essentially like an improvement of about one letter grade for the building. And obviously, it also comes with carbon emissions reduction because we're reducing gas consumption from wasting so much air that's coming and traveling through the building.
So, was this building looking to reduce penalties under Local Law 97, and will this affect their penalty
Yeah,
exposure?
so the building was not, in part because of the first project that we did, they're not expected to have any new penalties in the first cycle and the second cycle, I believe. But this really helped, achieve a reduction from the third cycle of about 100. I think I just looked at the numbers, about 170 tons, if I remember correctly. So it really just, helps overall story.
Clearly, comfort was a big issue as well as the
Yeah.
savings generated. So, what are some of the takeaways from this case study for other boards who might be listening?
I mean, I think the biggest takeaway is that every capital need needs to have, you need to think about it, one, holistically, but also ask the question, can I do this better? Replacement of A with A sometimes does not solve a problem. You got to think, can this save me energy? Can this save me operating expenses? Can these save me carbon emissions? So, especially for such critical large equipment as a cooling tower, as a rooftop unit, as exhaust fans, chillers, and boilers. Like there are ways to piggy write off capital projects and reduce energy and carbon emissions.
You said that the building was constructed in 2008. Is there a risk with some of these newer construction where the sponsor has moved on and perhaps, as a result, these HVAC units aren't correctly sized or commissioned? And is that something that buildings, sort of the newer construction buildings, should be considering then?
Hard question to answer, and I've actually spent time thinking about it because I don't want the owners of new construction buildings to feel like they're just not getting what they hope for. What I will say is this: I've seen a lot more mechanical problems and operational issues with newer construction than I have with some of the older. However, I don't know what is the cost of that. And sometimes I wonder if I put myself in a, pre-war building and it was like 1942 right now, would we still be dealing with some of the issues that these newer constructions, does it take a cycle or two for a building to actually learn how to operate optimally? I don't have the answer to that. Obviously, I can't travel in time. So I don't want owners of newer construction to be discouraged, But I will say that just on what I've seen, we do see some programmatic, issues that just are operational headaches for the operators for the building.
You mentioned designing these upgrades holistically, but also is it helpful to perhaps phase in these improvements so that these adjustments can be made to optimize improvements?
Yeah. I think Local Law 97 is giving buildings the opportunity to think like that. So luckily, most buildings are not going to be affected by the first cycle of Local Law 97. But buildings need to be thinking about what are the capital needs of that building and how those capital needs can be tied into carbon emission reduction. Right. So I think you have to pair the two. If you have a very expensive facade project coming up, you need to be having conversations with your architect about like what can we do to improve the insulation of the walls. Is there anything that can be done? There's one architect that I like to follow their work, And whenever they do a facade project, they also spend time improving I don't have the technical terms, but improving the windows so that when the windows are replaced in the future, it's an easier replacement so they can install better windows. So it's just like thinking forward. Is there anything that can be done to reduce infiltration? So these are things that like buildings just need to be thinking about.
Yeah, so basically looking for every opportunity to improve efficiency.
Yeah.
Thank you
Yeah.
so much,
Yeah. Absolutely. Yeah. Thanks for having me. And we're always here to answer questions.
Great. Amalia Cuadra, Senior Director of Engineering at npower Group.
Thank you, guys. Take care.
Does your building struggle with ventilation, rising energy costs, or new compliance rules? npower Group helps co-op and condo boards take control. We improve comfort, cut costs, and help you stay ahead of local laws. With more than 23 years of experience and over 900 completed projects, we design upgrades that make buildings perform better. From ventilation and electrification to energy audits and compliance plans. Visit enpg.com to start planning smarter improvements for your building. npower Group, engineering what your building needs.